Okay, we will start it. See, once again I will show you problem. This is the problem. 60 kilonewton meter, same problem. 100 kilonewtons, 3 meters. It's a 4 meters. We take an MA and MB are the unknowns. MA and MB are unknowns, so we release it. It will take it as a two simply supported beams. Simply supported beams, it's like simply supported beam, it's a determination. So we have to find out the rotations here. Rotations. So what is the rotation here? So how to find out? By the conjugate beam method. By the conjugate beam method, it is easy. So by this conjugate beam method, we find out the 160 by A. And we have to also find out the in the direction of the M2 also. What is M2 direction? It is M2. So it's MB. So in this direction also we have to find out by the rotations here. So both, because this is a load, by this load you have deformation here, by this load deformation here. So what is that? This is 160 by A. Here it's a this value, both are we add it, this will come here. So now you have a doubt here. Sir, what is the doubt? Sir, here if you see here it's a maybe the rotation is anti-clockwise direction. Here the rotation is some clockwise direction. Why you add, sir, both? Maybe I have a doubt. You may get also doubt. Why you add, sir, both? So these are the two opposite directions rotations, sir. Get it? Get it the idea? Okay. So you get idea. So but I will say this is some tricky. How it is tricky. So I will take MB as a hogging moment. If you take hogging or sagging, anything. So how it is acting on the giant hogging moment? If it is a hogging moment, how it is acting? So if it is 2, I said hogging moment of some MB. How it is acting? If you write a free body diagrams, how it is acting? Hogging will act for this beam in this direction, for this beam this direction. We already solved so many fixed beams from the structural analysis also. From the structural analysis, if it is a hogging moment or sagging moment, how it is act? If you write a free body diagram, it has a minus 50. If you write a free body diagram, it will act like this for this direction, this for this direction. If you take in rotations, it will come to this rotation, it will come to this direction. It is this direction, it is this direction, both are opposite. So finally we have to find out this MB has certain hogging or sagging. No need to, don't say it is a clockwise or anti-clockwise. For a moment of MB or MA, you have a specific hogging or sagging, not positive or negative. That is the problem. Okay, that is the problem you arise it. So now for this purpose I took it as a hogging moment or sagging moment. For that, if you take an MB as a 1, either sagging or hogging, you have to add it. This will come this one direction, this is come another direction. The response of only one, the response of only MB. So you may be confused. That's why I said it has some problem. Okay, so now you can see. Okay, I will solve the same problem in another. So now you have to understand why it is I added it. Not one is one direction, another is another directions. You have to subtract it. You may feel it, but no, it's add. It is the same effect. That is in joint. That's a joint. Rigid joint has certain different idea. Okay, so that's it. I find out this deflection also. Now we can develop a stiffness matrix. Now flexibility matrix. Flexibility matrix. Flexibility matrix. Flexibility matrix of that flexibility matrix we have to develop on a free diagram. Understood? Not exactly not this diagram. So not this. You don't feel. You don't put a fixed end here. You don't put fixed end here. You don't put joint. No, flexibility matrix or stiffness matrix we have to develop once we release those unknowns. Previously, if you see, if you taken a previously, if you know here, so flexibility matrix stiffness matrix we developed it by arrest everything. See, arrest everything, arrest here, arrest everything, and we release the only those unknown direction. One, I took as the first one is this is, I release one direction and we taken as a forces here. So first we took everything is fixed, everything is fixed, everything is fixed, and we taken this is the one joint. So at this joint we allow 1 unit rotation, 1 unit rotation. So like this, the flexibility matrix or stiffness matrix, we have to find out when in a stiffness matrix we arrest everything. In a flexibility matrix we release a static inerrancy. For that release structure only we can find out the deflection and slopes. If you are directly see, if you taken like this beam, you never find out the slope and deflection here. You can't find out the slope and deflection because it's fixed. But we take an MA and MB are unknowns, so we release those two, and for that released structure we have to find out the flexibility matrix. That is also a one point. Okay, so that's why released structure. What is that released structure? Released structure is here. That's it. That's it. These are the released structure now. So we can take it. So for this structure you have to find out the flexibility matrix. So how to find out the flexibility matrix? Very easy. You have to apply a unit force and find out the deformation. So for that MA, if you take in clockwise anti-clockwise, flexibility matrix doesn't change. I said it's flexibility matrix doesn't change taken clockwise. So if you take in a clockwise direction, clockwise movement or anti-clockwise mode, anything, if you take in a clockwise of 1 unit force, you have to find out kF11. F11 means what? Force. See, deflection generated when the unit force is at the location of 1. If you applied a unit force here, how much rotation here? How much rotation here? Very simple. We already know. If it is 1, so write down the bending moment diagram. Write down the bending moment diagram. It will come to like this is 1. I write bending moment diagram 1 only. Here is a bending moment diagram is what? Okay, sorry. Bending moment diagram is going to be this 1. Write down this curvature diagram 1 by EI. So 1 by EI you will get curvature diagram like this, curvature, and you have to find out the shear force here. You will get the deformation, you will get the rotation. That's it. So it's divided, so there is no transfer of moment from this to this. Okay, so directly you can write F11 is shear force here. What by here? What is total? 1 by 2. This is length is what? 1 by EI and 4. That is the total force. What is the shear force here? It's a triangular. It will come 2 by third. It will come 1 by third. You already know. So that's it, 2 by third. So how much it is? It's a 4 by 3 EI. So same thing. F11. Okay. F21. F21 is rotation at the second end. At the second, this you taken as this is the direction of MB. Okay, if you applied a unit force at first joint, what is the deformation at the first joint? What is the deformation at the second joint? So second joint, it's a 1 by 3 only. There is no transfer of here. So same. It's a 1 by 3. It's a 2 by 3A. Okay. Now comes to the second part. That is the important. Second part is second MB direction. Sir, MB. So clockwise or anti-clockwise. That is the problem. MB has a hogging or sagging only. Now here you taken what is the direction? This direction you taken. So this is or both are same. Okay. You taken as a not a sagging. It's taken as a hogging as a positive. You taken as a hogging as a positive. Here also you taken hogging. For that hogging, how you feel it? Hogging, how it is? If you feel it, it will come to this direction. That's it, hogging. So MB is taken as a hogging as a positive. Here also hogging is taken as a positive. Otherwise sagging also taken positive. That's deformation also in the same direction. That doesn't change it. Are understood? If you taken as a, if you applied a moment here, it will come deformation here. If you applied a moment here the deformation will come in the same direction. In the force direction only deformation will come. Okay, that's why there is no change in stiffness matrix and flexibility matrix based on the direction. But if you take in this is a hogging, this is a sagging, finally also you feel it is a same. If you take in positive value will come, hogging only will come. That's the only observation. Okay, so now you can see if you applied a MB of unit force unit force in the hogging direction, unit force, so how it is behave, how it is unit force at the joint unit force you have to apply it, unit force you have to apply it on the joint. So how it is, it takes everything like this only, don't feel it is here also it's 1 by a. Giant has a force of 1. Force means that's a moment. Giant has a 1 moment. It will, everything is a simply supported. So don't expect, sir, it is a rigid giant. So some part it has based on the stiffness only. It will distribute between these two giants. You may come to the rigid giant. You feel it is. No, it is a simply supported beams. It is a simply supported beams. Now it is a deformed structure. All understood? Don't confuse. It is a rigid giant. It is split between those two by their stiffness. No. If you applied a 1 at the giant, both has taken as a 1 because both are the simply supported beams. So it will comes to this. It will comes to this. If it comes to this, so you can observe it. You can write down delta 2 at 2. 2 direction 1 force and 2 direction. What is that? Here. Both you have to add it. So same thing. Here is 4. Here is 3. You already know it. So write down 1 by 2. 1 by a 4. Here it will come 2 by third part. 2 by third part. Here also 1 by 2. 1 by a and 3. Here also 2 by 3 part. 2 by 3 part will come. Shear. If you find out the shear, it will give us the slope. This is the conjugate beam method. You already know. Conjugate beam. Conjugate beam. What is this value? This value is 7 by 3a. And also if you know, it's a 2, 1, 2. At the 2 direction we will unit force. What is the 1? So this day here is what? Same 1 by 2, 1 by a and 4. It's 1 by third. It will comes to 2 by 3a. No need to find out here because these two compulsory equal. Stiffness, not a stiffness. Those are the symmetric. Those are the symmetric matrices. No need to calculate it. So now you can see. Now you can see. Write down. Now you can write down. See, I already said. So delta is stiffness matrix. You can write stiffness matrix into force plus this delta is balance it. That's it. So these are the final deflections. These are the free deflections. If you release the structure on those two static indeterminacy, how much deflection will get based on the stiffness matrix and those forces, those two are balances, it will give 0. Sir, every time it's a 0? No chance. When the final settlements may be there. Next problem I will show you where it has some force. Okay, now we can write down these values. What is F? Stiffness matrix is 4 by 3a, 2 by 3a, it's a 2 by 3a, and it's a 7 by 3a. Force, it's a M1 and MA and MB. And the deflections, okay, and the deflections. Now you can observe it, what direction we taken a deflections. Here we taken as a hogging moments. So now you can observe it. Here we taken a hogging moments. Hogging as a positive. If you take a hogging moment, which direction it will comes to? Which direction? Those rotations will come upside. Na? So if you taken sagging, okay, no need at all. If you taken like this, if I said I said I I said sagging taken as a positive, sagging taken as a positive, sagging taken as a positive, sagging taken as a positive. That's also same. These values doesn't change. Here also sagging as a positive, sagging value as a positive. These are the hogging moments. Okay, hogging or sagging. Okay, 1 minute. I confuse it. These are the hogging. Okay, if you taken these are the hogging, hogging. Okay, here also if you taken hogging, hogging, hogging as a positive. No change at all. The stiffness matrix doesn't change. I said the deformation is in the direction of that force only will come. If you taken hogging as a positive, okay, hogging as a positive, fix it. Hogging as a positive, stiffness is the same. If you taken hogging as positive, if you taken hogging as a positive, if you see it is how much direction it will, how much direction the deformation will happen, how much direction the deformation is happening. So deformation will happen here, this direction. Here also, if you take an hogging moment is positive, hogging moment is positive, how much, which direction, the direction it will come, this direction, this direction. Are understood? Same, this direction will, the deformation will occur if you take an hogging. So what we find out, we find out the deformation in this direction, we find out the deformation in this direction. We take in the deformation in the same direction. If you add it, both add it, we will get it. If you see, if it is some force is there, if the force is there, this is F, this is X. F, if you take in this direction is positive, F, this is a minus X equal to 0. You can write it. If you taken this, its east side is positive. If you taken F is in east direction, X is in west direction, that's why we taken as a negative. Both are equal to 0. That's the same. My observation is, if you taken the deformation here, you taken a deformation in this direction, you taken as a positive, this is a, you taken as a positive, yes, you taken as a positive in this direction. Here if you taken this direction is positive, no, you have to assume it either one is a positive, one is a negative. So you don't take in everything is a so you can write it like this, you can write it like this. If you, one is a positive, one is a negative, that's it, na? For this, you assume you taken this direction, this direction, this direction, this is also you taken this, either this direction, this direction, this direction. So these values are negative values, these values are negative values, either one is. If you taken, if you see here, you taken as a hogging direction, flexibility matrix doesn't change. If you taken this is a hogging, this is also you taken as a hogging is a positive, but he is, see it is, this is a sagging we taken. So either one is positive, either one is negative, either was anyone. So that's it. I write is a, this is a negative 160 by EA, 216.5 by EA equal to 0 0. So now you can take, so flexibility matrix MA and MB is equal to the 160 by EA, 216.5 by EA. So MA and MB, how can you write? You can directly solve two equations, otherwise you can inverse it directly. 1 by EI, this is a 4 by 3, 2 by 3, 2 by 3, 7 by 3. Inverse it, inverse it, and also you can 3 also you can directly write it. So what is the debt? 728, that's it. 28 minus 28 minus 2, that's the debt. 1 by 3 you can outside 3 and inverse it. Inverse it means, so you inverse it, minus 2 minus 1 4 inverse of this, and directly you can write 760 by a 216 by 5. This is the inverse. Now we can find out MA and MB. MA and MB you will get is in a positive values. What is that positive values? 85.87. MB is 68.25. That's it. So you taken as this is hogging. This hogging moment is positive. In this direction is a positive. The final moments also in this direction only. In this direction also the final moments are this direction. That's it. So MA will get this same direction, MB also in the same direction. So now you can see, you can write down the, this is 85.87, so this is 68, this is 0. You can write down. So this is uniformly distributed load. It will get, it will come. Okay, like this you will get it. Okay, so that is the confusion in the confusion at the location of a joint. Sir, a joint has how we don't add, we don't add those, we don't subtract one another, because at the joint it behaves too different. At the joint it behaves too different. Are understood? So that is my understanding. Okay, okay. That's it. That's it. You can solve the problem, but the same problem I will solve another method, another two unknowns I will take as the two, those two are another unknowns. So a small problem will come, so see, the same problem if you took it as same problem if you took it is VB VC as taken as unknowns. Okay, this is VA. I will took these two are the redundant force. If you release those two, what will come? Release structure, it will come like this, 160 kilonewton per meter. It's a 4, it's a 1 point, so what is, it's 1.5, it's a 1.5. Release it, just release it, find out the deformations, deformation means is, if VB is in the direction, VC in the direction, those are the forces, not the moments. So you have to find out the deflection. You want to find out the deflection, it will comes to, so at the VC direction you have to find out the deflection, VB direction you have to find out the deflection. Later you find out the flexibility factors, multiply with these two unknowns, final deflections are 0. Final at this direction deflections are 0. Those are the two complement each other. Are understood? That is my logic. First you release those two unknowns. Find out the deflections. Later you find out the flexibility matrix, multiply with these two, will give us the deflections in the same direction, deflections in those two directions at the two locations. Those two complement each other, it will give 0. Based on that you will get VB and VC. That is the idea. Okay, so can you calculate the deflections here? Based on the conjugate beam method, it's too difficult because it is not a straight line, it is a gives a parabolic, and also not an exact parabolic. So if you take in like this, if you write down the bending moment diagram up to this, it will give, later it will give the, if it is taken the same 100, it will goes this, and here it will comes to parabolic here in this direction, because the 100 into 1.5, so 150. Here also it will increase up to 100 to this 4, so it will increase like this only. But this effect also will come, this effect is parabolic formation in this direction. So can you find out this area? And you can't it, you can find out the deflection in another way. another. So many, we have so many methods, strain energy method, everything is methods are there. So many methods are there. So that's why it takes something, it takes some time. So I avoid this loading. I will change the loading only. Okay, but the problem is same. I will change the loading because the difficulty in finding the difficulty in finding the deflections. But you will do, that is your assignment. The same problem you can do the problem by taking these two unknowns, VB and VC are the unknowns. But I will change the loading because of the finding the difficulty in finding the deformation diagram. But you can find out the deflection here. You can find out the deflection. That's the only difficulty. Remaining everything deformation, flexibility matrix, everything is same, because that is dark. Flexibility matrix doesn't depends on the loading. It's only depends on the conditions or the redundants only. Okay, so I will change the loading. I will change the loading. I will change the loading. You have to do it. Now you can understand. Simple. Okay, this is where is 80 kilonewtons. This is 40 kilonewtons. I will take this is a 2 meters, 2 meters, but simplification. This is also 2, this is also 2. Okay, the same structure. I will change the loading because of the finding the deflections is difficult. You can find out, not impossible. It's possible. You can do it. Okay, so now you can see. Just remove. I took VB and VC are the two unknowns. So remove it. Remove it. Remove it. It will goes to this direction. So you taken VB and VC are the two unknowns. You have to find out this delta. Here you have to find out this delta. So those are the two forces. You have to find out the deformation. So that's it. So can you find it? Can you find it? So we can find out by the conjugate beam method only. So how can you write on the bending moment diagram? Can you write bending moment diagram? So for this topic here, this is 80, this is 40. Remove it, remove it. This is remove these two. Can you find out? Easily find out. So bending moment diagram, can you write it? This is fixed, so it is free, it is free, it is fixed. Conjugate beam method. So bending moment diagram, it's a 40 here, location is 0. It increases up to here is 80. It increases up to 80. Later up to here 40 into 4 160, so it will increase up to this is 160. So at this location 40 into 6 plus 80 into 2, this is 160. This is also, what is this value? 240, 400. So at this location is 400. It's the same, not slope. Up to this has same slope, but this is different slope because 80 also adding. So this is a 400. Divide by EA. You can took divide by EA. Divide by EA. This is a bending moment diagram. You want to find out the deflections at here and here. You can find out the bending moment at those two locations. Not here. Here. You find out the bending moment at those two locations. You will get this exactly the deformation. So deflection. So that's very simple. So now you can see the deflection you calculated, it's downwards. So that is my downwards. Simple logic. So later you can take it. So to club it at the time you have to take in those directions are very small, careful. Okay. So find out. First you have to find out here bending moment. Can you find out? Very easy here. This is 2, this is 2, this is 2, this is 2. This exactly, if you take in this dabba is, what is that value? 160. 160 by EI multiply with 2, and exactly here, what is this distance? What is this distance? 160 by EI multiply with 2, total area, multiply with distance. Distance is what? 2 plus 3, that's 3. Exactly 3. That's it. That's it. And here, this value is what? 160 minus 400 minus 160. What is this value? This value is what? It's 240. So 240 by EI is half into 2. That is the total area. Half into 2. That's the total area. And the center of gravity here lies here. So 2 plus this value. This value is what? 2 by 3 of 2. Okay. 2 by 3 of 2. So 4 by 3. So the distance is 2 plus 4 by 3. That's it. This 2 plus 4 by 3. That's it. This location is over. This part is over. Here now this part. This part also has two parts. This part also has part. This part is 80 and this part also 80. So here also you can take 80 by EI multiply with 2. Distance is 1. Distance is 1. Now it has also weight is 80 by EI half into 2. Distance is 4 by 3. Okay. Distance is what? This is the distance. The distance is what? 4 by 3. 2 by 3. It's a 4 by 3. That's it. That's it. What is that value? This value is 2026.67 by EA. Now by the same analysis, you can find out the moment at here. You can find out the moment at here. You have to find out the distance. Now this. Only everything is area is same, but the distance is small change. So if the distance is small, distance is higher, na? Moment is also higher. So just do it the same and you will get 5706.67 by EA. So these are the deflections you taken as a downwards. These two are downwards. If you taken as a downward positive, these two okay. If you taken downward is negative, these two should be maintained negative. That's it, na? You should maintain that these two are negative. That is your choice. I don't compel you. Okay. So later, now you can find out the flexibility matrix. Flexibility matrix. So now we can observe it. The flexibility matrix find out the later once we remove the redundants. This is the flexibility matrix. Are understood? This is the flexibility matrix. So where are these? These two are VB here and VC here. This is the flexibility matrix. Na? Remove loading. That's it. Now you can feel it is. If you take it downward, you feel positive, or downward you can take negative. Which one is? If you taken, see, if you taken previously taken downward is, if you taken these two are positive, you can took downward is positive. Or downward if you taken as a negative, negative, you can add those two are negative signs. That's the only idea. So previously I said, if you taken it is negative or positive, choose both. So pre-deformation diagram and later flexible diagram, both are, if you taken the same sign, then if you add both, you will get 0. Understood? That's my idea. Okay. So now you can see, I will took as a, see, downward is positive. Downward is positive. So that's why you can choose a positive sign. Now you can apply a downward force. Downward force. This is the first. This is the second. You can take it as. Okay. That's first and second. Release the structure. Those two. Now you can see. Now you can see. Find out. First you can apply a unit force here. Unit force here. Apply a unit force in the direction 1. How much the deformation in the first direction and second direction? What will the deformation direction? It will the deformation here. So what is F11? F11. What is F11? If it is, this is a, how much? This is a 4 and this is also 4. You can easily find it here. You can easily find it. Can you find it? So you already know W. So what is that value? If you applied a PL cube by 3A, PL cube by 3A. Otherwise, you can find out by the flexibility way. So conjugate beam method also. By this conjugate beam method, you can find out. You can find out conjugate beam method. conjugate beam method. Bending moment diagram, you can write it. How can I write? So here one, it was bending moment is 1 by A. It is a fixed diagram. You can find out here is the bending moment. What is the bending moment? What is the bending moment? Directly write half into 1 by A into 4. 1 by A into 4. That's it. Half into 1 by A. So sorry, there is bending moment is 4 by A, because if apply is a 1 unit force here, multiply with 4 moment is 4 na, moment is 4 by A, 4 by A multiply with 4. Distance is what? It's a 4 into 4 by 2 by 3. Distance is 4 into 2 by 3. That's it. Otherwise very simple is PL cube by 3A. So what is PL? P is now 1. L is what? 4 cube 3A. Directly you will find delta A. The same thing you will come. What is that value? This value is 21.33 by EA. It is very simple by this PL cube by 3A. Already you know it. 1 4 cube by 3A. 4 into 4 into 4. You will get 21.33 by EA. That's it. Very simple. Otherwise, you can find out by the conjugate beam method. If you don't remember the formulas, you can find it. So that is F11 and F21. F21 same, you can find out the bending moment here. Now the distance will change. Otherwise here, you already know this. You already know. I said so many times. This the rotation is same. Rotation is same here. So you can find out this value is. So I said this value is 21.33 by A. Remaining this value is what? The slope. Slope is what? PL square by 2EA. Slope into distance. Distance is 4. Slope into distance is 4. That's enough. Slope is same. What is that slope? PL square by 2EA. You already know. We did so many times here. Otherwise, same. You choose the distance here. What is the distance? Distance is this is 4 and this is 4 into 2 by 3. The same value. Okay. 1 by 2, 4 by A into 4. The distance is 4 plus 4 into 2 by 3. What is that value? That value is 53.33 by A. Here is very simple. Now we can next you have to apply this direction, unit force. What is this? You will get it. What is that value? You will get what is the value? F22. What is that value? PL cube by 1, L cube. L is 8 cube by 3A. So what is that value? That value is 170.67 by A. F12. What is that F12? Here what is the deflection? You can't find out by directly formulas, because you have to use Maxwell reciprocal formula only. So what is the Maxwell reciprocal formula? This is the only Maxwell reciprocal formula we did it. This is the example I took it. So exactly this value will come same thing. Otherwise you can use the conjugate beam method. Conjugate beam method will come like this. This will come 8 by A. Here is, you can do it. Conjugate beam method. You can easily find out. But no need to find out, because both are the same. That's it. Now flexibility matrix over. So you taken as a downward is positive. Everything is downward is positive. Now you can write down. So flexibility matrix what is? 21.33 by A, 53.33 by A, 53.33 by A, 170.67 by A. What is that? VB and VC plus you will get what is what is those values? Deformation values are 2026 2026.67 by A, 5706.67 by A equal to 0, 0. Both are complement each other. Downward is positive. Second is downward is positive. Everything you downward is positive. You taken downward is positive. Previously also downward deflection you taken as a positive. So now you can find out the VB and VB. So every time EA and you can cancel it. EA you can cancel it very easily. No need to find out. So directly you can find out VA and VB. What is that VA and VB? Can you find out? VB and VC. Can you find out? Which values? The values will come negative. Because if you outside it will come negative value. Write down the right. Can you write down? So can you write down these values? You will get, see, EI will cancel. 21.33 multiply with 170 multiply with 53.33 whole square and inverse the matrix. 170.67 minus 53 minus 53.33 21.73 and 2026.67 5706.67 will come negative. It will go outside. Okay, negative. So what was those values? VB and VC will come 51.05 16.76 negative will come. That means what? The values, the VB and VC will come upwards. We taken a downward is a positive. We taken downward is a positive. So we will come negative means it will upwards. That's it. That's the idea. That's why if you taken everything in the same direction, you will get the final forces in some one direction. You can assume which direction it is. Otherwise, one and one direction. If you same thing, if you taken the same thing here, the flexibility matrix doesn't change when if you taken upward is positive. Upward is, if you taken upward is positive. See, suppose if you taken upward is positive, the flexibility matrix doesn't change. This value doesn't change. Upward is positive. These values will come what? Upward is positive. These deflections will came at, you see, if the deflections will came at downwards. So upward is taken as a positive. These will come negative. This doesn't change. This doesn't change. If it is negative, the final values will come positive. You already said upward is positive, so these values are upward. That's it. That's it. Exactly same now. These values are upwards. So this value doesn't change. This matrix doesn't change. By this direction of this VB and VC, you have to change these two directions. Finally, you will get which direction these VB and VC are. And also, finally, once you just feel it is, remove those redundants. You find those deformers here. Those two unknowns are those two. Not only two. Those forces, those redundant forces, the directions in those redundant forces, we write down the flexibility matrix. Those two complement each other. Final resultant deformations are 0. Previous same thing, here also same thing. Now you can go the previous same MA and MB. You can feel it. You can feel it is, and you can take the directions also. Okay, so that's it. Now we can find out the VA and VB has upward directions. The VB and VC. VB is 51, VC is 16.76. Once these two, can you write down? Can you write down the can you write down the bending moment diagram? Can you write down the bending moment diagram? This is very simple. Now we can. Otherwise, I will write down. This is 51.05. This is 16.76. This is 40. This is 80. So can you find out the moment here? This moment is 61.72. And what is the moment here? Moment here 16.76 multiply with 4 multiply with 16.76 multiply with 4, 40 into 2. So this is 80. This is 64. So maybe 20 something. So 20 something you can find out. So can you write down the bending moment diagram now? So this is 61 point something, this is 20 something, this is 0, and it will go like this, and it will go like this. Okay, we write down the free body diagrams also. This free body, this is 61 point something, this is 20 something, this is 20, and this is 51. This has something, this has something. You can easily find out. Once you find out the unknowns, these two redundants, you can find out anything. The same problem now we can see. Sir, every time you feel these are the two zero zero, sir. No chance. So which direction? The same problem I will take it as. I will write the same problem. A small modification. Small modification. C. Very small modification. Say analyze the continuous beam. Analyze the continuous beam if the downward settlement of supports B and C are 10 mm and 5 mm respectively. That's it. If you see the final downward settlements, we already solved these type of problems in slope reflection, moment distribution, Carney's method, and fixed end moments every time in a matrix methods. See the downward settlements of supports B and C are 10 mm and 5 mm. So the final deflection at the supports of B and C are 10 and 5, not 0 0. Are understood? Not 0 0. That says same thing. If any problems, the final in the stiffness methods also how it is, I will show later. In the deformation, in this flexibility matrix, the final settlements maybe maybe final rotation also may be there. Certain way it can't possible. Finals at certain, if you can't allow certain rotation in fixed support. In previously structure analysis I said fixity means maybe 100% may can't it, maybe 80%, 90%. If you 20% allow 20% rotation, if you allow it like the situation, but most problem will comes this step in. There is no chance in rotation. Sorry, there is no chance in rotation. You can't it. But the settlements we have chance. The final settlements at B and C has 10 and 5, not 0 0. So that's it, the same problem, no need to do it, it's the same problem. So see, final settlements in the downward direction, these are the downward directions. So now you can see which direction we taken, everything is a negative, so downward direction is positive, we taken it. Downward direction is positive, we taken it. So final settlements will have, so downward directions only, these two are 10 and 5. Are understood? These two are 10 and 5. So downward. Are understood? These two are 10 and 5. So where it is? Same diagram. Where it is? Sorry. Previously we took as a positive. It will come as a negative. Okay. Same problem. These two complement each other, but see the final downward settlement is 10 and 5, not 0 0. So you just add, this is a 10 and this is a 5. Downward is positive, you have to take it as a positive. That's it. So do the same. Are understood? Do the same thing up to this, and you have to write down like this: 10 and 5 B and C settlements, the same matrix: 21.33, 53.33, 53.33, 170.67, 1 by A, VB and VC be taken as positive of what? 2020, 2026.67, 5706.67, 1 by A. Just solve it. Sir, Here previously here you have EI, we can cancel it. Now if you this value, if this value comes to this direction, one has EI, one has, there is no EI, so that's why I will give EI. Without EI you can't solve these problems, so I will give EI value as 184 into 10 power 11 Newton mm². Without EI you can't solve it. If you taken those EI value, so now you can solve it. The same flexibility matrix VB and VC 1 by EA, it will come as 10 5 minus 5706.067 1 by EA. If you place EA with this value, and what was those values? What is these values? Those two values will come as a 0.1 and 0.305 will come. If you place it here, minus will come. Okay, minus will come. Okay, that's it. So now we can find out VB and VC. Same, these values. Once you know, you have to also place it VA value and find out the VB and VB. You will get it's a 18.48, 27.05 minus. You will get it. You will get it. Okay, you will get it. Same thing, but just a small change. The final settlements of 10 and 5 at B and C mm. So you have to just not it's a 0 0, it's a 10 and 5. Understood? Otherwise how it is, sir? How it is? If you taken a matrix methods also, if you taken these are the final matrices and this is the 6 by 6 matrix plus these are the fixed force vector, right? So at this we eliminate, we eliminate those two. Here those two are not 0 zeros. Just we equate those two, this vector and this vector and equal to this vector. Every time these two are zeros only, we will get those unknown forces. Previously we saw it. Here these final settlements are there. It's a fixed values. These are the fixed values. If you compare flexibility matrix and stiffness matrix, previously we solve it. How it is, how those strike out, how only these two values are 0 0. How in a stiffness matrix. In this matrix also these two values are 0 0 because every time these are 0 0 when a fixed conditions, because these are the supports only. These are the supports only. If you remove it, these are the redundants, na? VB and VB. The forces are generated means the deformations you arrested it. If the forces VB and VC are generated means what? The deformations you arrested it. So the final deformations is 0 0. Not any fixed conditions. The fixed condition here, the supports also settled by 10 and 5. If the supports are settled, extra moments will generated, the forces will altered. Then only that type of situations only will come, those two values will come. Those two, 10 and otherwise every time is 0 0. And if you taken as a stiffness matrix, I said every time the forces are 0 0 those two, but any support has a fixed end moment is there like this at the support. Every time the support has at the support, the moment MBA MBC is 0 0 only, but the support has a concentrated moment. That moment is concentrated moment is equal that moment. The force is also to taken. I will solve so many problems day by day, one by I will solve. I will show different conditions. Okay, so that's why it's not 0 0 every time. It has certain values when the certain fixed conditions will are there. Okay, now you can see the same problem we solved it. You will got it. You will got these values, and if you write down the say this value is 18.48 now, this value is 27.05 now, this value is 40, this value is 80. So now what is the moment here? Can you find out the moment? This moment is 109.22. Can you write down the bending moment diagram? So this is 109, and here is a 28 moment. Here is a 28.42. It's a 109.22, and you can write down this. You can write down, and you can write down shear force also. You can write down the shear force also. Okay, it is a 28.42. It's a 28.42. It's a 27. It's a 40. It's a 40. It's goes to be 13 something. Now it's 12.85. Understand? It's a 12.85. If it is 12.85, it is 6. It is 6 point something. It is 6 point something. It is 80. It goes to 74 something. It is 109 point. You can write down shear force everything. These are very basic mathematics. That's it. That's the end of the story. Now I will give the assignment. I am giving the assignment. You can solve the same problem. The loading is the what we assumed as a previous problem loading. Okay, this loading you have to take, and this is the loading. Do the same problem. So you can find out the deflections. That is the only small flexibility matrix. Everything is same. You have to find out those deflections. You can find out the deflections by different methods. You already know the deflections chapter in strength of materials. I think 10 times, 6 to 7 ways you can find out the deflections. And I also explained the deflections in the fixed end beams chapter. So conjugate beam method, area movement method. So many methods. You can choose those only enough method. Do the assignment. Okay, that's it. You have any doubts, ask me. Otherwise, we will close the session.